Okay. Can you all see my screen? Please let me know if you can see my screen.
Yes, ma.
Yes, I can see your screen.
Yes, can see your screen.
Yes, I can see your screen.
Yes, we
Yes, I
can
can
see
see your
your
screen.
screen.
Okay, all right, great. All right, great. So I prepared this slide for lesson 1 for today. So it's going to be 4 lessons for manual A to Z manual software testing, and then we'll do API testing. So lesson 1 is a bit large. So we want us to focus and pay attention, because this will form a foundation of whatever you get to know eventually in software testing. All right. So manual software testing. So I'll be treating fundamentals of software testing, consisting of what is testing, why is testing necessary, 7 testing principles, test process, and the psychology of testing. So just like I said the other time, I said the idea is to ensure that all these apps you see on your phone and on your laptops, as simple as it is for you to be able to use it as a user. So, and for that to happen, all right, something has happened somewhere, that there's been a development of that application, and there's also been a testing of that application. So software testing is a process. Number one thing you need to know is that software testing is a process, meaning that the end product that you see is not just it. It started with a process from A to B to C, and then D, and then Z, before you're able to use the application. It's a process, it's an action of checking whether something work under certain conditions. All right. When you go to buy your electronic appliances, what do? You don't just buy it and oh, it's working, and then you buy it, and then you bring it to your house, and then you put it on, and then you notice it's not working, right? That is not sorry, I need to admit people. Hold on for a second. Let me close this. Close. Okay. Okay. Just like as I said, it's not wise for you to just buy an appliance and then for you to discover that it's not working properly without testing it where you buy it. It's good that you actually test it and you check and you see that it's, and that is what it is. You test to check that your software is working according to requirements. All right. So can we still see my screen?
Yes, ma.
All
Yes,
right.
yes.
So we
Sure.
said software testing is a process to check whether the actual software product matches expected requirements and to ensure that the software product is defect free. And software testing, what software testing does involve the execution of components or system being tested, such as there's dynamic testing, there's static testing, and whatever you are testing, you are comparing what is the requirement. By saying requirement is like a big ground. By saying requirement, what and what should this software do? All right. I always say that when there is something, there's an application, when there's software and it is not usable, then what is the essence of it? Okay. So a software tester will check, we confirm that okay, this application is what is usable for the user. There is a specific user in the mind of the developer, in the mind of the product owner before developing the application. Oh, this user is supposed to be a businesswoman. It's supposed to be a business owner, an SME business owner, and she's supposed to have a microfinance account, okay, and she's supposed to be able to at least have a savings account, all right, and also have a current account. What am I trying to say? I'm trying to say that, okay, for certain banking apps, they are designed for certain specific users. All right. So user consideration is important when it comes to what software testing, and when it comes to requirement, it's all about what the business wants. All right, business requirement. Okay, so that's what software testing is all about. It is a process of checking whether an application, a software, under certain condition, will it work properly according to requirements. That is software testing. All right. And when you test, why do you test? You test to prevent defects. You test to ensure that defects are not passed on to the application. You test to identify errors. You test to close gaps or even missing requirements. It is very possible that when they were gathering the requirements to design that software, it is very possible that some requirements were missed out. Okay. And so as the tester, you discover that before we actually design this feature, we should actually include this feature and this feature. Why? Because it was omitted in the what? In the requirement document. Okay. What is all this requirement document I've been talking about? Now, this is it. Business owners, all right, product managers or project managers or business analysts, sometimes they conceptualize ideas. Oh, I want to design an application, a traffic application that will be able to track traffic offenders. All right. We want to develop an application that will be able to track traffic offenders. And we want to ensure that whoever gets whoever the offender is, the application is able to like screenshot their plate number, all right, or the application is able to match their plate number to their vehicle ID number and all of that. Okay, so probably while trying to conceptualize that idea, some features were omitted, some requirements were omitted. It is very possible. And then the developer just gets on to what? To develop this application. So that's why we always say that testers are supposed to be what? To be involved from the idea conceptualization to the development phase up till the end, to maintenance and all of that. When we get to software development lifecycle, we'll be talking about that. All right. So conservation of ideas, it is from there that business owners start writing their requirements. Okay, for us to design a traffic application, these are the things that is required. Number one, all right, business requirement number one, the user must have a driver's license, all right, must be a resident of Lagos State, must be this, must be that, and all of that. All right, those are requirements. And then you're also saying that the application has to be mobile application, whether Android or iOS. Okay, you're also saying that they will be authenticated by their email, or if you are not using that, by an ID, okay, or by their national ID and all of that. So requirements are defined and there are documents for those kind of requirements. And in some methods, depending on the company, some of them don't write documents because technology is evolving. A lot of them are just go straight to designing the application, not implementing, mind you. They just design workflows. Oh, from this to this, and then they put arrows. Or they can make use of all this Figma document and show how the application interface is supposed to look like. And then those are what? Requirement, defining requirements. We are saying that for that application, for us to be able to install or use the application, these and these are the conditions, all right, for the application to work and for it to be available to the end users. Okay, that is what all those grammar of requirement, that is what it means. All right. So we are saying that what a tester's work is a tester is supposed to check, confirm that all these requirements, all right, they are working properly. There are no errors, there are no gaps, there are no missing requirements, there are no defects, all right, and that the actual the expected result is also the actual result. All right, that is the work of what a software tester. In this slide you will see this image is trying to show us how a normal software tester look like. I mean, if you are working as a software tester, sometimes these are all the things you put in your front. Sometimes you have to use an iPad, you have to use a laptop, desktop, mobile phone, different kind of mobile phone, different kind of browsers, and all of that. While you are trying to test that, okay, when they operate this application on a desktop screen or a larger screen, this is how it will look like. And if I'm operating it on a mobile device, this is how it will look like. Is it working as expected and all of that? So that is how a software tester works on a normal day. All right. Let's move on. So I said testing and debugging. Now, if you look at this my material, you discover that it's different from the usual materials that people use for training, because I actually sat down to compile and to edit and do a lot of work on this slide. So it's going to be available to you after the lesson. So let's continue. So I said testing and debugging. So both these two things can be mixed up, but they are very different. All right. So executing tests always shows failure caused by defects in the software, and that's what testing is all about. But what is debugging? Debugging is like a process or an activity you do to find bugs in a software. So what you are doing is you are looking, you are running an activity, you are running a process, you are running a code, all right, to analyze and look for where the defect is for fixing. But for tests, you are running test itself. It's not the application you are running test itself to show, all right, failures, to show defects, to show errors in the application. That is the difference. So we said in some cases, testers are responsible for initial test and the final confirmation test. And subsequent confirmation testing checks whether fixes are resolved, and then it shows the defect. But for the debugging, in some cases, developers do debugging, associated component and component integration testing. When we get to types of software testing, we will discuss that in details. All right. So can you still see my screen? Just to confirm that we are all in this together.
Yes, we can.
Yes, can see your screen.
All right, great. So I have a lot of slides here, so I need to move very fast. But there will be a chance for questions and answers. So try to listen, to go through the slide as I'm explaining, and then prepare your questions. So we said, why is testing necessary? Why do we have to test an application before pushing it to users, before pushing it to other business people to use? All right, because the application softwares are not only meant for users, they are meant for business people to use. All right, an example is this PowerPoint I'm using now. This PowerPoint is also an application, and we know it's from Microsoft, right? And it's majorly a B2B. Okay, it's majorly a B2B. I mean, business to business. So sometimes it is a business that makes use of your application. So what you are saying is that why should you actually test that application? All right. So we say rigorous testing of components and systems and documentation can reduce risk of failure. So what a developer is doing, why for his development, is that he just sees it. He might not even understand, at least in the initial phase, he might not really understand what the application is all about. The most important thing is he got the document, he got the functional requirement document or technical requirement, he got some documents, and then he started working, started developing. And before you know it, the application is complete without testing. Imagine, the application is complete without testing, and then you push it. I know a lot of us have experience with some apps already. you download some apps from Google Play Store, and then you see terrible reviews on them. In fact, some of those apps are no longer there, because once the ratings get to something like 2.1, Google Play will remove it. All right. So there are applications like that. So it is important, it is necessary to test. Why? Because it will help to reduce the risk of failure, and defects will be detected, and then quality of the application will be improved. All right. So having testers involved in requirements reviews or user story refinement could detect defects in this work product. Having testers work closely with system designers. So as time goes by, you will understand who a system designer is, who a software developer is, who a product owner is, because all of these terminologies are what a tester gets used to. You have to get used to it, because in a software development life cycle, I mean in the process of developing a software, all right, there are people, there are stakeholders involved in that development. Some people sat down and crafted the requirement document. Those kind of people are probably the product owner, and then the business analyst, and then the project manager, and depending on what industry we are working in, all right. And then the people that sat down to develop the application are the people we call what? The developers, the software developers, the software engineers, all right. And some people were involved in pushing the application to an environment, or some of them the DevOps engineer, development operations engineer, and so on. So as time goes by, you get used to who and what functions these people actually perform in software development life cycle. And so people are designers, we call them product designers. All they do is they pick the idea, they pick the requirement document, and they design it in such a way that it becomes visual. You can see what to expect in the application. All right. So having tester verify and validate the software before releasing it, we help to detect failures. So failures of the application, such that it's possible that while I'm developing it, in fact, sometimes developers run some little tests, and sometimes those tests, in running some of those tests, they will still miss out some elements, or some functions, some failed function, they miss it out. And as a tester, it is your job to detect those failures. All right. So at the end of the day, that is why we test. Those are the reasons for software testing. All right. So why do we test? I think I'm done with that one. Okay, so there's a difference between quality assurance and testing. Maybe you've been seeing quality assurance engineer, software quality assurance, software testing. All right. There is a difference between what? Quality assurance and testing. Some software tester perform quality assurance role, software quality assurance role, while some software testers only do testing. All right, depending on which company or which industry you find yourself, you'll be operating in these roles. All right, so let's look at it. Quality assurance management includes activities and control with regards to what? With quality. And let me just as easy, as simple as possible. So consider an onion. You know, an onion has a lot of bulbs within it. So the outer layer of the onion is something you can call quality assurance, and the inside layer of it you can call it quality control. And maybe the inside layer is what? Testing. All right. So what I'm trying to say is that testing is a subset of quality control, and quality control is a subset of what? Quality assurance. All right. Now, quality assurance is focused on what? Processes. Quality processes. All right. While quality control talks about testing activities. All right. It involves what? Testing activity. There are a lot of testing activities that will take place while testing an application. All right. So that is what quality control is, and that is different from what? Quality assurance. All right. So we said since quality assurance is concerned with proper execution of entire process, quality assurance supports proper testing. Anyway, proper testing is like an inside layer of what quality assurance. So at the end of the day, all of these roles are what are intertwined. They are interrelated. All right. So errors, defects, and failures. What is error? What is defect? What is failure? What is bug? All right. So these are the words I've been saying since. I said when you test an application, it's possible to detect defects. I mentioned defect, I mentioned failure, I mentioned errors. All right. So there are different terminologies. Sometimes it can be an error that you detect in a software. Sometimes it is defect that you detect. Sometimes it is failure. So these things are different depending on the application. All right. So we said a person can make an error, which can lead to the introduction of a defect. So while writing your code, developer put comma where you're supposed to put dots. All right. And then before you know it, by the time you run the application, you discover that a fault or a bug, maybe the bug, the bug, maybe the link is broken and all of that. That is like a fault or a bug in the software. Um, okay, so an error that leads to introduction of a defect in a work product can trigger an error. All right. So when this error leads to a defect, this particular error that is introduced in the code can lead to what? Can lead to a defect in the application. Eventually, maybe where the user is supposed to receive a recovery link for their password. All right. And then they discover that the page for the recovery link is broken. So that is defect already. A comma in the code led to what? Led to a broken web page. And at the end of the day, it becomes a defect. Why? Because for that user cannot recover his password. All right. So that is how it gets interrelated. It said from an error, it leads to a fault or a bug, and then it leads to what? A defect. So, for example, a requirement elicitation error can lead to a requirement defect. That's another thing. It's also possible that while designing the requirements, all right, we have talked about requirements the other time. It's possible that while designing the requirement, it's possible that some things were omitted, some features were omitted, and then the developer did his own homework, developed the application according to what he saw, what is in the requirement document. But eventually, it's a defect. Why? Because it was an omission. All right. The business owners or the business use case is supposed to include those features, but they were not included. So it's a defect. So they will need to go back to the requirement, redefine and add those features, and then the developer would need to now go back, add those features to the application. Then that means after adding it, then the tester will be ready to what? To retest that feature. All right. So we said if a defect in a code is executed, this may cause failure. That one is we already said that, but not necessarily in all circumstances. For example, some defects require very specific input preconditions to trigger a failure, which may rarely occur. All right. So let's move on. Those are just terminologies you need to know while testing your application. Next thing says, just like I explained the other time, it said they are all subsets of one another: testing, quality control, and quality assurance. Just like you can see here in this diagram, you see that testing finds defect in a product. Quality control will evaluate the quality and see if it meets customers' expectation. And then quality assurance will define and improve the quality processes. All right. So just like onion bulb, you discover that testing, quality control, and quality assurance are entwined. Okay, let's continue. People are joining us very late, but we will continue because we still have a long way to go. All right. So we have several testing principles, and it's more like a guide. I call it 7 guiding principles. Okay. So as a software tester, this should be your principle while testing. So number 1 says testing shows the presence of defects, not their absence. So the real reason you are testing is because you want to see, you want to check that, oh, defect is in this application. You are not testing to say, oh, there is no defect. All right. You are testing to see that, oh, there is defect in this application. So testing shows the presence of defect, not what. The moment you are trying to test and you are checking that there is no defect, then you are not testing. All right. So testing shows the presence of defect, not their absence. Exhaustive testing is impossible. So what exhaustive testing means is, it means to say, I have executed all my test cases and I'm sure everything is 100% passed. Is it possible? No. In testing, we call it 99 points, 99111, whatever it is. So there is no perfect system. The truth about it is, no matter how many times you run your test cases, or no matter how well you have written your test cases, it is still possible that some test cases were not included, or that the application, by the time it is pushed, it's still possible that something will fail somewhere. So of course we put in our effort. We put in our effort to ensure that the application is 99.99%, is of quality. But then exhaustive testing is what? Impossible. So that's principle number 2. The third principle says early testing saves time and money. All right, this is very true. So yeah, we are testing an application for a reason, and the reason is because we don't want to go to market. They call it that way. We don't want to go to market with an application that will fail, or that the customers will start complaining about. I tried to add my product, to upload my product, and it says that the size is too large, or there are a lot of things that can happen. So if eventually an application get pushed to life and customers are assessing it, and then they discover bug, all right, discovery of those bugs will waste time and money, because as at that period, that application is supposed to start making money for the users. I mean, for the business owners, it's supposed to start making money. But by that time, you start fixing bugs. All right. I mean, fixing of bugs is supposed to be done prior to what? Releasing that application. But because it wasn't done properly, it was released and then they started using it, and now they need to push it back again. So it will waste time, it will waste money. All right. So early testing will save your time. If you start testing early enough, right from requirement gathering, you start testing early enough up to development stage, up to deployment and all of that, then it's going to save time in the long run. Because no matter how much you rush, some people will want to jump test cases. They will jump, they will squeeze up two scenarios into one. By the time we get to test scenario, we're talking about that. They will squeeze it up, and then before you know it, they've omitted a lot of test cases they're supposed to check for. And then all of these things, because you are rushing because of that, at the end of the day, you will still come back to it. So you have wasted time. But it is always a matter of what? Slow and steady. Make sure you gather all the test cases that you need to gather first. Make sure they are well constructed. Now, no matter how slow that process is, they still need to be done. So after doing all of that, then you can run your test cases, and then you can be sure that your application is ready. All right. So what we are saying is early testing saves times, it saves money. So the first one says defects cluster together. What does that mean? It means that in a scenario where you see a defect or you suspect a defect, it is possible that there are other defects within that same scenario. So don't say this one has passed and then you jump. So defects do what? Always cluster together. So take note, make it a principle of yours while you test. Beware of pesticide paradox. What does that mean? Beware of pesticide paradox. It means that if you continue to use the same test cases for a feature or for a component of a software, it is possible that after running it the first, the second, the third time, that those test cases will no longer detect defects. It is possible that they will no longer detect the defect. It means that it's just like pesticides. When you apply pesticides to mosquitoes or to insects, if it is the same pesticide you apply all the time, it will come to a time when those insects will develop a kind of immunity against your pesticide, and then you keep applying, and you just discover that when you apply it, they will just go and hide somewhere, and after after a period of time they are back again. All right, so that is what pesticide paradox is talking about. We are saying that you should continue to review your test cases. You should continue to add more to it. So if you keep running the same test cases for a feature, and then you are not checking conditions, preconditions, and all of that, it will come to a period, a point in time when those cases will no longer be effective. It will no longer detect defects in your software. We said testing is context dependent. It means that the way you are going to test a desktop application is different from the way you are going to test a what? Mobile application. And some mobile applications are also different. A payment application is different from what? An e-commerce application. All right. And it's also different from what? An e-learning application. So it is what? Context dependent. Now, we also have absence of error is a fallacy. What does that mean? It simply means that for you to say, I have tested this application and it is 100% perfect, it means it is a what? Fallacy. So when product owners ask you and they ask the testers, because in a lot of organizations, it is the keywords that give the go ahead to push an application. Oh, we want to push the application, we want to expose it to customers, they need to start using it and all of that. So the keyword need to give a go ahead. Oh, we have closed test on this thing, it has passed the exit criteria, now we can push, and it is 100% free of error. Is a lie. No matter how much you test it, absence of error is what? Is a fallacy. All right, is it not interesting? Let's continue. We said testing activities. Test process consists of test planning, of monitoring and control, analysis, design, implementation, execution, and completion. What that means is you plan your tests, and there are certain activities that take place while planning your test. All right. So what you are saying at this moment is the documentation ready? That is the requirement document. Is it ready? Do you have access to it? All right. That is planning, test planning. All right. So you are, and then in monitoring and control, you want to be sure that, okay, the testing environment is also ready. Okay. What is testing environment? You get to learn that as time goes by. Analysis is talking about how you analyze the application. All right. So when you have gone through the requirement document and you have gone through the design, you are analyzing what and what we testing this application, what and what should we do. Is it an application that already has some test cases somewhere? Perhaps if that is the case, then what and what should we do now? Are we supposed to add more test cases? Are we supposed to review the test cycle? All right, and and a lot of other things is also done under test analysis. When we get there, we'll talk about it. Okay, so test design is talking about how well you design your your test cases. All right. So now that you know what and what to do, analysis is saying, oh, we want to do performance testing, we want to do functional testing, we want to do non-functional, everything. You already know what to do. All right. So by the time you get to number 4, the test design, you start writing those test cases based on what and what you're supposed to do. If you are automating the application, you are writing those test cases. All right. So you are designing your test cases, your test scenarios, and all of that. For implementation, it's like you are checking if your test is actually passing or failing. All right. Executing, you are running it over and over, and you are getting if it is passed, FTR, test cycle, and so on. When we get there, we'll be explaining that. Test completion is saying now that we have executed test cases, we have executed these test cases. This is the percentage passed, this is the percentage fail, this is the recommendation, all right, and so on. So that is what test completion. So these are the processes that take place when you test. When we get to proper testing, we are going to be considering all of these things one after the other. Now, what is traceability matrix? We said there's test basis and what? There's test work product. Have we talked about test basis? Did we? Okay, no, we've not talked about it. Okay, so test basis is like, just like I mentioned the other time, there is requirement document, but much more than requirement document, there are design documents. There's something called design document. There's something called process flow diagrams, something called flow charts. All right, flow chart will now show when user login, they must see the login page. No, when user sign up, they must receive an email. After receiving an email, they must verify their account. After verifying their account, they must go back to the web page and log in. After logging in, and then you now see the flow charts connected with arrows showing the user flow processes, showing that okay, it is customer. When customer is doing this is what happened. When the manager is doing this is what happened. When this sales executive does this is what happened. All right, it's showing flow from one layer to another. I think I must have listed test basis. Test basis. It should be somewhere here. Did I omit it? Okay, let me go back. When we get there, it should be below or okay. Let's continue. Okay, so what I'm trying to say is, so after we have something called test basis showing what and what should be developed. All right, requirements for development. Okay, that's the test basis. And then there is something called test work products. All right, so after the developer has implemented the application, he has designed those functions, and then they are working well, and all of that. It is good to always compare whatever the developer has developed. You compare it, all right, to what is elicited in the words to what is listed as requirement in the document. All right, so you compare and you check. So analyzing the impact of changes, what has changed. The way it is written in black and white is different from the way you are visualizing it now as an application. So how has this thing changed? Okay, right? Analyzing the impact of changes, making testing auditable, meeting IT governance criteria. Okay, so is it meeting the criteria stated in the IT governance document? All right, so improving the understandability of test progress report and test summary. All right, hold on, let me check something. Okay, so let's continue. So relating technical aspect of testing to stakeholders in terms that they can understand, providing information to assess product quality, product capability, project. All of this might look like grammar for now, but by the time you sit down with this document and then you digest it, because we'll be practically, actually the essence of this training is to practically lay hands on applications and test them as you will test it in real world scenario. All right. So all of this is to give you a background knowledge of what you're working on. So that is what traceability is all about. And in some companies, in some industries, there is even a document called traceability matrix document, and it is like a requirement. All right. It is something that the tester will work on, but not in all cases. So, and when you are doing that, you are checking your test case that has been implemented, you are checking it against what has been defined in the business requirement document. They call it business requirement document. They call it functional requirement document. They can call it technical requirement document, and so on. So you are checking what is implemented against, you're comparing it against what is defined in those documents, and you are tracing and checking for gaps so that it can be closed. All right, that is that. Let's continue. All right, let's continue. We said psychology of testing. Developers and testers often think differently, and it is not just developer and tester that thinks differently. When you get to work with all of these stakeholders, product manager, product owner, business analyst, software developers, their psychology when it comes to software testing is different. And as a software tester, your own psychology too is different. So if you understand what their psychology is, when you start working with them, you don't have any problem. So a developer's the way a developer will test his own application, it will be testing so that it will pass. You know, one of our 7 testing principles says that testing is what? Is the presence of defects, not the absence. Okay? But what the developer is doing is to check that there is no what? There is no defect. So their own psychology is different from what? From our own psychology. So testers and developer and tester, they think what? Differently. And the primary objective of development is to design and build. We know that. Or a tester's mindset should include curiosity, professional pessimism. Pessimism means that you are always believing in the negative, that, oh, I am very sure this application will not work. Oh, we are not praying. It's not that you are praying that the application should not work. Don't get it wrong. But it is a normal professional psychology for a tester to think that it will not work. You have a critical eyes, you pay attention to details, and a motivation for good and positive communication relationship. So a tester mindset tends to what? To grow and mature, and as testers gains experience. All right. So as times go by, as you work on more products, your experience widens and you get to understand more. All right. So your mindset as a tester should be that you pay attention to details. All right. It should be that you have a critical eye. It should be that you are motivated, and it should be that you are communicating, because you must always communicate. When an application has defect and they need to be fixed, you communicate. Even when they are fixed and you have retested, you communicate. So you always give what? Feedback. All right. So a tester mindset tends to grow and mature as testers gain experience. So that is the psychology I want us all to develop as we progress with this training. So software, the next thing we are considering, the next phase of this training talks about testing throughout the software development life cycle. If you recall, the first was what? Fundamentals of software testing, and everything we have covered so far right now is what is software testing, why is testing necessary, 7 testing principles, test process, and the psychology of testing. All right. So this next phase. We have software development lifecycle models, we have test levels, test types, and maintenance testing. Let's continue. Okay, it's almost 7. Okay, I still have 1 hour more for teaching before we do question and answer. So we have software development lifecycle. We're probably used to hearing SDLC, SDLC, SDLC. SDLC is what? Software development lifecycle, and it's a series of phases. Okay. It provides a complete understanding on software development processes. So how the software will be realized and developed from the business understanding and requirement elicitation to convert these business ideas and requirements into functions and features to achieve its business needs. So from requirement elicitation to converting it to what? To functions and to a complete application on that test. That is what we call development life cycle. So from the moment where you gather your requirements, you really cite it, you define it in a document, you give it to the developer to develop. Developer gets to develop the application, and the application is ready for testing, and then you test and all of that. All of these processes, all right, from requirement elicitation, all right, to the moment the application is ready for its business needs, we call it what? Software development life cycle. Is a series, is a process, and it consists of phases. It's from one phase to another. So that is what software development life cycle. So software testing is what we call software testing is a process aligned with. So inside of this software development cycle is what we call software testing. So software testing takes place and is within the development life cycle. So there's something called software testing life cycle also. This software testing life cycle, just like we did just like we gave an illustration of the onion bulb the other time. So the STLC is like a subset of the SDLC. This STLC, that's the software test lifecycle, is like a subset of the SDLC. All right, it's like a subset of the SDLC. So any software, so what that means is that no SDLC is complete without what? The STLC. No development is complete without what? Testing. All right. So any software should have its testing cycle mapped to the main development life cycle activities. For example, if we are using waterfall model, we'll get to talk about the model soon. So if we are using waterfall model, the testing cycle will be different from using an iterative model, but it will have the main common activities in the process. So when it comes to SDLC, depending on the industry you are working, and also depending on what methodology that they make use in that company or in that industry. Now, if it is an iterative model they are making use of, there is a way the SDLC will be designed in such a way that the STLC will also be included. All right. And if it is agile or whatever model is being used, the STLC will always, all right, be integrated into what? The SDLC cycle. All right. So let's continue. So we said there are different software development models. Like I mentioned the other time, we have Agile, we have Lean, we have Waterfall, we have DevOps, all right? We have Spiral, we have V model, we have Iterative, all right? So we'll be explaining it one after the other. And if you have been working in IT industry, by now you should recognize what methodology is being used. When you filled out the form, there were so many junior QAs, but I don't know if they are in this meeting. We are looking at just 27 here and about 69 registered. So let's continue. Lean methodology is about eliminating waste. So you make decisions very fast, you develop very fast, you test very fast. The model is a what? Is a fast model, and it tends to eliminate any waste of time, right? And waste of process. So it's focused on eliminating waste, making decisions as late as possible, delivering outcomes as fast as possible, and focusing on the big picture. So project teams working with the Lean model find opportunities to cut waste at every step of SDLC process. In other words, skipping on important meetings, and reducing documentation. So in this kind of methodology, you will discover that they don't have documents for their requirements phase. This requirement document I've been talking about, some of them don't have requirements documents. So they don't have business requirement document, they don't have technical requirement documents, they don't have functional requirement documents. You ask for it and say we don't have, but they have something, all right? So when we talk about what they have, they will always have something, but they don't have all those documentations, all those meetings, 2-3 hours meetings, 4 hours meetings that some companies get involved in. They don't do that. They try as much as possible to reduce to cut away waste, because they believe that by doing so many meetings you are wasting time, you are wasting money and all of that. So they cut away waste, and of course it works for them. So as an alternative to documentation, we'll talk about what some companies have decided to use to as a guideline for their developers to develop their softwares. Instead of requirement document, they have something else. Let's continue. Agile methodology. We will get there. Agile methodology is very common these days, and we said is an incremental and an iterative approach. What that means is, what incremental is like saying that number 2, add 1 to 2, 3. Add 1 to 3, 4. Add 1 to 4, 5. So that one that you keep adding increases what result you are getting. It is incremental, just like mathematics. All right. So what we are saying is, when your application gets developed, they don't release a full application. They release it bit by bit in an incremental way. So if it is the login module that is ready, they release it. And then as a tester, you get to test it. And then when they plan their sprint, they get to plan their sprints based on small modular work that can be completed within like 1 week or 2 weeks. All right. So their process is incremental and iterative. So where the product is released on ongoing cycle, then tested and improved at each iteration. So at each sprint, so you discover that for this sprint, they test whatever has been okay. Some of us don't understand what sprint is. Okay, sprint is like a short is like a short race. All right. So, or let me call it a short project. So you have this whole project and you have decided to divide it into smaller components. All right. So you say component A and you assign it to 2 weeks. So this component A will be implemented within 2 weeks. All right. So maybe the component is supposed to be A to F, all right, for the whole project. So you decide that each component will be executed within 2 weeks, at least to the completion of the project. So you give 2 weeks, maybe the first 1 week for development and the next 1 week for testing and fixing of errors. All right. So within these 2 weeks, we are saying that we want to develop the whole of component A. That is what sprint is in software development. All right. So you plan a sprint and then you assign 2 weeks to it. In agile methodology, they quickly develop, they quickly work, and then they quickly release. All right. And when it is released, they test, and then it is fixed. It's as fast as possible. All right. And that is why there are different models within this agile methodology. There is something called the extreme programming. There's rapid application development. Extreme from the word you already know, very fast, rapid, fast, Kanban, Scrum, Crystal. So everything about agile is about speed. The faster you develop, the faster you release, and the faster. All right. Methodology. So for methodology, this one is a very old method, and it goes straight to the point. What Waterfall does is they've completed all their development processes and then release it before testing can take place. Right. So this let's say it follows a straightforward approach. The project development team completes one phase at a time, and each phase uses information from the last one to move forward. Why this methodology does make the needs and outcome clear and gives each stage of the model a well-defined starting and ending point, there are downsides to waterfall rigidity. Waterfall methodology is kind of rigid. They have a very strict documentation that they have prepared ahead, all right, and then they give it to the developer, and then they complete all the development process, all right, and then the next thing is, oh, let's give it to the testers, and then they start testing, all right. So maybe the tester now discover that these people have developed the wrong thing. What will happen after wasting all those time to develop? All right, so that is exactly the negative part, the like the consequence, the cons of what, of waterfall methodology. Because of its rigidity, a lot of other methodologies have evolved. All right, so let's move on. There's DevOps. DevOps is the combination of development and operations. So here you develop the application, and then you push, all right, and then it is tested, and then you deploy. So it's a kind of collaboration between business owners, product owners, developers, and testers. All right, there is always a development environment, and then they get to push the application there, and then they continue to deploy. They develop as soon as they develop, they deploy. Develop, deploy, and test. Develop, deploy, test. So based on that, what development environment that has been created. So in development operations, both developer and operation teams work together to accelerate and innovate the development and creation. So there are certain software that falls to this category. Of course, not all software falls into this methodology. So you can't always use this methodology for all softwares. But we know that there's always DevOps, like a kind of segment for every software industry. There's always a department called DevOps. But we also know that it is not all softwares that operate basically majorly based on this methodology. Okay, so there's V model. We say V model is a combination of what waterfall and agile. Okay, so similar to waterfall methodology, where testing is done at the end of a project, with the V model, testing happens at every stage of development. So agile is saying that we will do small bits, release and test. All right, waterfall is saying we will finish everything, release and test. V model comes in between and say, okay, we will balance it. You don't have to finish everything before you release and test. Let's just combine more than two functions of agile, maybe divide it into phases, phase 1, phase 2. When you have developed this phase 1, then when you are done with developing phase 1, you release it, you test it, so that at least if something is wrong, you can go back and work on it. It won't be after the whole application is completed and then you now want to waste another time just because you have developed the wrong thing. All right, so that is the balance that V model comes in to do. It balances what the agile and the waterfall model. So the next stage is spiral. We said as one of the most flexible SDLC models out there, spiral model is used by the world leading software companies. So spiral enables project teams to build a highly customized product. So spiral methodology passes through only 4 phases repeatedly until the project is finished. So that's planning, risk analysis, engineering, and evaluation. So the biggest difference between spiral and other methodologies is that it's focused on risk. So the major thing about spiral is this risk analysis, because we know that some softwares, if you don't analyze their risk capabilities, then you will be doing the wrong thing. So you have to analyze their risk capabilities even before you develop them. And after you develop them, before testing, you still have to analyze their risk capabilities. All right. So with each iteration, it focuses on mitigating potential risk. So there are potential risks in the system, they are identified, and then they are put into consideration while developing the application. So that is spiral, and that is why it goes through just 4 phases, and this is used for just risk products. It's not used in every scenario, it's not used in every organizations. All right. So we have iterative. What iterative is? Iterative allow developers and testers to identify functional or design flaws early and easily adapt to ever-changing needs of the client. So some clients will come to them and say, yeah, this is what we want, and then tomorrow they'll come and change it again. So iterative will get you to adapt to the changes that comes from the needs of the client. All right. So spiral iterative suits larger projects and requires more management oversight and work well. So all of these methodologies, in some organizations they make use of two of it, some just one, and all of that. So the summary of it is you identify what methodology is being used in your company. If you are working for a company right now, you should identify it and see how your testing process can sync into that. All right. Let's continue. So I have some images here which you can go through by the time we share this document. So we said this is a spiral model and this is iterative. So spiral model, we have you determine the objective, we have the test plan, development plan, and it is reviewed, and then you plan the next iteration. We also have the development and testing and all of that. So just go through it. Iterative says you initialize and then you plan. All right. Then you have the requirement, the design, the implementation, the verification, and then what? The evaluation. All right. So waterfall and agile. We also have an image, an image here saying the difference between waterfall and agile. All right. So we have in waterfall, like I explained, I said the whole application development is completed and then testing comes up after. All right, just like you can see here, you can see these requirements. This is requirement elicitation, and then from there you design the application, and then you develop it, and then you test it, and then you support the application. That is waterfall. But if you look at agile here, you discover that it starts from planning. All right, from planning, you have requirement gathering, you have design, you have the architecture, you have quality assurance. Quality assurance meaning that all the processes it takes to test your application, we've defined the difference between quality assurance and quality control the other time. So when you're saying quality assurance, you already know that it covers everything. All right. So your testing is included at this phase, and then you launch the application. So we have that. Let's move forward before we start taking questions. So we have the STLC. So we talked about STLC the other time. Now we are kind of trying to make it more detailed in this slide. So we said STLC is software testing life cycle, and we said software testing life cycle is embedded in or is always in sync with what software development life cycle, and every STLC model has a what an STLC model by its side. All right. So for STLC we have requirement testing, we have test planning. You write your test cases, you execute your test cases. After executing, you give feedback, and then after giving feedback, you retest again, and then you conduct the user acceptance test, and then you close. All right. So I will explain one or two things that I've not explained before. You already talk about requirements. What it means is that you gather things you're supposed to test. Are you testing on a laptop, phone, a device, mobile number? Will you need mobile number? Everything that is required. All right, you gather them for testing. All right. So planning talks about what and what's when how long will this testing take? All right, you know how long, what effort should be put into it, what types of software testing should we do? Is it functional? We have non-functional? Will there be performance? Will there be smoke? I mean, that's when we get to types of software testing, you will know more about that. So that's what test planning. You are planning and then you are planning. All right. So writing test cases is comes after test planning. All right. So all of this, when you sit down with them, you will really understand. So writing test cases comes after you have planned. If it is functional testing you are conducting for the application, you write your test cases, and then um you include scenarios, you include expected results, actual results, and so on. And then it is executed, and then you take feedbacks. Now, what I really want to explain in this STLC is user acceptance test. All right. So what user acceptance test is doing is to validate that our software is ready for the what? For the customer use, or whoever we use the application is ready, it can suit the business needs. All right. So we said this should be the validation activity with the end users who will use the system to ensure that they are working correctly from the business perspective. There's been a perspective you've been using before. If there's been this time around, you have to use a user's or a business perspective. Okay, this category of users will be using these applications. Oh, it is the SME business owners that will be using this application. Then you come from that business perspective and then you test the application. So this can be iterative as well after the customer report some defects. So what we are saying is user acceptance tests, if it is not conducted, then you can't close your STLC. All right. So your STLC is closed. That is, it means that you have completed your software testing process when you are sure that you have done what? Your user acceptance test. That is what is important in this page. All right. So we have testing closure. It is important to know when we should stop testing, explore the testing findings, and learn from the cycle from new. So whatever you are testing, until you have done your user acceptance test, you cannot close this. You cannot close software testing. All right. So we have SDLC phases. So SDLC versus STLC. Now, we said SDLC starts from what? Requirement gathering analysis. All right, see analysis here. So the analysis will include product owner, project manager, business analysts, CTO, so many stakeholders, depending on which industry we are talking about or which company we are talking about. So we have the analysis, then you have the design phase. So this is being done by the UI UX designers or the product designers or system architects. All right. The next phase is what? Development. This is front-end developer, back-end developer, full stack developer, whatever developer. All right. Then we have what? Testing. So testing, we have solution architects, we have QA engineers, we have testers, and we have what? DevOps. By now, you should have, I mean, every of these words I mentioned just now, every of these stakeholders, you should get used to them by now, because I've mentioned some of them more than once in this training. So testing, a QA engineer, testing can be done by a QA engineer, can be done by a tester, can be done by a DevOps, can be done by solution architect. It's just depend on what they are testing in this scenario. All right. So we also have deployment. We have the data administrator, the DevOps, and so on. Then we have maintenance. So these are the phases of what? The SDLC phases. Now we also have the STLC phases, from requirement analysis to test planning to test case development to test environment setup to test execution and what? To test closure. So yeah, that is what the SDLC and the STLC. Test basis. Oh, I think this slide is supposed to come before this page. Okay, so before I release it, I'll make an adjustment. So this is the test basis I've been trying to explain for a while now. I said before a developer starts the development process, or before testers start any work at all, they are supposed to be exposed to what? To the test basis. And we also said some SDLC models, some SDLC models does not make use of some test basis to do their work, right? there's something called requirement document. All right. And this requirement document could be business requirement document, could be technical requirement document, could be use case requirement document, could be user stories requirement document. All right. They are just grammar. You can research more on them and read them up. All right. So whatever is inside, they are just functions or use cases or scenarios or what else can I call it? Business needs, all right, that should be developed in the application. Those are the things that it contains, all right, and that is what you get to have before you develop or test your application. So we call them requirement documents, and some organizations don't use this, all right, but let's continue. Test plan. So your test plan is designed by the tester. All right. So before you start testing, you should have a plan. All right. So there is a document called what? The test plan, and usually designed by testers, test manager, test lead. All right. So we also have code repository. So your test plan, by the way, should also have a timeline, and the people that will be involved, your team that will be involved, the timeline, it should have the kinds or the types of we conduct on that application, that include your test plan, and should be available before you start testing. All right. And code repository, in some organizations they make this available for their testers. All right. So they by that, but they must have pushed the application and you must have been given access before you even start testing. All right. There's also process flow diagram. Okay. So this is what some people use in the place of requirement documents. So instead of requirement documents, they will give them process flow diagrams. So instead of saying user should be able to do this, do this, do this, do this, and then they write it in grammar in white and black and all of that, what will they do? They will just draw diagrams and connect arrows to it. Triangle, rectangle, connect arrows to it, and all of that. Flow chart, all right, showing the process flow of the application from one user to another. Okay. So some organizations, some companies make use of process flow diagrams. Some make use of just product design. All right. That one will show the interface of how the application will look like. When you log in, this is how the page will look like, and they will design it. And by the time the application is fully implemented, that's what you will see. All right. So they design from one web page to another, from one mobile interface to another. So that's product design, and then you see how it's going to operate from the user and from the user's perspective even before it is implemented. So that kind of design, they make it available for you, and when you look at it, when you see it, you understand what your test cases should look like. All right. So you just go through it, and from there you can start writing your test cases. You can start testing. All right. So for some risk products, there's a risk analysis report. This one will enable you to know what are the risk features that you're supposed to test for and all of that. There's also legal contract and sign-off document. Okay, so for legal, for some product, maybe government product or big products, all of that, they need to sign some contract and all of that. So they will make this available to you if there is a need for it, and if it's needed, it needs to be included in your test. All right. So there's also sign-off document. You know, some applications have been tested before, developed before, and then maybe you are redesigning them now, adding new features. Maybe it is now version 1, version 2. So you need some sign-off documents. I mean, documents that like maybe test closure document and all of that, that has been signed off on before now, and all of that, for you to actually understand the application that you are testing. Okay, so we also have user manuals. So because some applications, like I said, are not new, some of them are just upgrade, version 2, version 3. So because they are upgrade now, you need to see user manual. It's not in all cases anyway. You need to see user manual for you to design what your test cases will look like. It is your test cases you will use to test the application. All right. So that's the list of test bases. It can be more than this, but I've taken time to compile this list. So that is what test basis. Test levels talks about the kind of testing you conduct on your application. Now, this is the most important and like an interesting part that I will need us to follow. We have component testing, we have integration testing, we have system testing, and we have acceptance testing, and it is in levels, just like as you see, it's levels. So from component testing, you move on to integration testing. From integration testing, you move on to system testing. Then from system testing, you move on to what? Acceptance testing. Now, what is component testing? Component testing is you testing each unit of function in your code. The application has not been pushed. The developer just finished writing his code. And for each function, each line of the code, he has written a test function that will test through that will test through the function or the module that he has written. That is what we call what unit testing. It will test that component and ensure that component is working well. That is what component testing is all about. It is look at it. It says it focuses on the components that are separately testable. And the component testing is often done in isolation from the rest of the system. So that one alone, that function alone, you test it alone and you see that it's working. Then you write another test for another function and you see that it's working. Okay, this one is also working. You write it for another one and you see that it's working. All right. So in some organization, it is not the tester that writes the component testing. In some organization, it is the developer that writes it. And in some, it is the tester. So depending on where you get to work, component testing, um, component testing is like unit testing, or okay, it's also known as unit testing or called module testing. All right. So from component test, you move on to integration test. So we say integration testing focuses on interactions and interfaces between system and packages. So just like I said you write each of your functions that you test, but for integration, instead of running just one function and checking that it is passed, you run multiple functions together at once. All right. So you are ensuring that function A is integrated to function B, and you are checking that the fact that it is integrated means that its interface should also be integrated together, and then it is working and is displaying on the interface as it should. So that is integration testing. So it focuses on interaction and interfaces between systems, packages, and underlying microservices. So for an application to run itself, you should know that some services are working on the background. All right. And for you to see that login page, okay, we will get there. We just need to complete this document. Okay, for you to see that login page, oh, welcome, login, you should know that there are some underlying what services that are running on the background. Okay, so what integration check we do is it will not just test that login component and see that it is working. If you see that that login is working well with the service that is connected to it, so that by the time you log in, it will be telling you that service is not available. All right, service unavailable, server problem, or check back in an hour, and some other error message that you might see. When the developer tests, oh, it's working on my hand, it's working on my local system, my tester is working. It might be working on their local system, or maybe it's perhaps when it was pushed to that environment, then it started failing. All right, so it's possible. So integration testing is important in this scenario to check that now that it is on a different environment, now that we have services working on this environment, each of these functions are integrated together and they are displaying externally as it should. All right. So that's integration testing. There's also system testing. It focuses on the capability of the whole product together. Now, this is not just login, and this is not just email service or login service. All right. This one now is talking about end-to-end testing. All right, is also another name. You can also call it end-to-end testing. You are ensuring that from sign up to home page to payment page to whatever page, all right, they are all working in sync. They are working together. All right. So that is what system testing. And there's something called acceptance testing. We're saying acceptance testing, like I explained earlier, may produce information to assess the system's readiness for deployment and use by the customer. It is always the end user when it comes to what acceptance testing. Your focus is on the end user, and the user acceptance testing of a system is typically focused on validating the fitness for use. So you are checking how fit is this application for use. Can the end users use this application? Is this what they want? Is it working properly on that environment? And so on. So is it displaying what is the usability level and all of that? How fast is it? All right. If 3-4 users are using it, will it break? And all of that. It's just for the users. All right. So that is what acceptance testing. Now let's move on. We have types of testing. Don't forget what we just considered is what test levels. Now we are talking about types of testing. We have functional testing, we have non-functional, we have white box, we have black box. So the other time I said, when you are planning your test, you are planning how long will it take, you are planning what types of testing will be involved. All right. So now when you are planning what types of testing will be involved, you are thinking about this function. Is it functional, non-functional, white box, black box, chain related, and all of that? Okay. Now let's explain what is functional testing. We said this is a testing technique, because I really try to make sure this document is not as big as this, but no matter how I shorten it, you will still need to go through them, because these are the things that will guide you by the time you start you really start testing. All right, you need all of this knowledge. So types of testing: functional testing is a testing technique that is used to test features and functionalities of a software. So the functionalities of a software that is already there's already listed in the requirement document, or that is already provided in the business requirement document, functional requirement document, the product, you are checking those functions. This system should be able to do this. All right. So that is what functional testing. And examples of functional testings include what? Unit testing. We mentioned unit testing. What is another name for unit testing? Can someone remind me? If you are following us, what's another name, another word for unit testing? We mentioned it earlier.
Component testing.
Yeah, good. That is what? Component testing. So component testing can also be called what? Unit testing. So it's an example of what? Functional testing. So when you are doing your unit testing, you are running functional testing. So system testing is also functional. We also mentioned, we explained system testing earlier. We explained integration testing earlier. We explained user acceptance testing also. So all of this, the only thing that we have not explained under functional testing is what? Regression, smoke, and sanity, which I'm going to explain now. All right, and I'm also going to give us an assignment. All right, so for regression test is that testing you conduct after a defect has been detected in an application. So, and it has been detected and it has been fixed. Don't let me say just detected. So is that testing you conduct after a defect has been detected and fixed in an application. So you conduct a regression test to check, to confirm that the fix in a component has not affected other components or the entire application. So what am I saying? I am saying that instead of retesting just one feature that was fixed, you should do what? You should test the entire feature. Why? Because it might be that one feature, other features has broken, or one feature somewhere in the system has broken. Then you need to conduct a regression test to be able to ascertain that everything is working as expected. That's regression. You regress, that is, you go back and check. So we have smoke. Now, smoke testing is usually conducted after what's the name, acceptance testing, or before acceptance testing. Usually conducted before acceptance testing. What do I mean? What I mean is there are some areas, risky areas, or critical functions, or the most important functions in an application that must it is like the exit criteria. When we get to exit criteria, you will understand. That is, what are the conditions that these applications need to fulfill before it is pushed to the end users? If those conditions are not met, then we cannot push. So when you are conducting your smoke test, you are checking for those areas. You are looking for areas, functions that can easily break. All right. You are looking for critical functions that can break, or areas that have resulted to failure. You will include that in your smoke test. You will list that as part of your smoke test. So you will list a lot of those things, risky functions, critical functions, application functions that can easily break, all right, and so on. That's what we call smoke. So they are the smoke areas, and they need to be tested before you push it to the user. All right. Then they call something sanity checks or sanity testing. It can be conducted before testing and after testing. What I'm trying to say is, when an application has been fully developed and you give it to the tester to test, the first thing you do is a sanity check. You check, is this application even installable? Can I even install it on my on my phone, on my laptop, on my iPad, and all of that? Is it installable? If it is installable, it is usable. Okay, it has the major things we need. The entry criteria checked, then we can start testing. All right. Now, it can also be conducted after the testing phase. All right. So what we are trying to say is, before it is released, has it met all of the exit criteria? All right. That is the sanity. Is it sane enough to go to the end users? Is this application sane enough to do what? To go to the end user? It's also you also conduct sanity check at that point. All right. So the assignments they remind me assignment already prepared. So the assignment is research on regression to smoke test and sanity checks, and produce the similarities and the differences between smoke test and sanity test. All right. Let's continue. Non-functional testing. This is a software testing technique that verifies the attributes of the system, such as memory leak, performance or robustness of the system. And what examples of non-functional testing include performance testing, security testing, usability, efficiency, reliability. So after doing all this acceptance, regression, integration, unit, and so on, you want to still check that, is this application, is it usable? See the colors of the application, and this red color, is it not too red? Why are they even using red? All right, those are the things you check for. Okay, now if many users are using this application at the same time, all right, if they're using this application at the same time, will it break? All right, maybe have you come across those web application before, and then you keep loading and it keeps rolling and loading and loading, and it's telling you that, hold on for a second, hold on for a second, hold on for a second, and it is not opening. Why? Because a lot of people are using it. We used to experience that. There's one portal like that, I won't mention it, that so many people, so many students are doing it, that you are making use of it at the same time, and then before you know it, the thing will start loading, and it will be so slow and dragging. All right. Why? Because it was not properly tested under load. Now, because so many people are using it under load, it is failing, or the speed and performance has reduced. So these are the kind of things you test, you check for. Call it performance testing, security testing. The security testing too. How vulnerable is this application to attacks, web attacks, phishing attack, and a lot of attacks? So you check. All right, and there are security softwares for doing this. All right. And there's also how reliable, how scalable, how efficient, and so on. That's what we call non-functional testing. Now there is white box testing. White box testing is a technique, is a testing technique in which the software's internal structure, design, and coding are tested to verify input output flow and improve design usability and security. So what we are saying is that there are some categories of software testing that belong to white box. And white box is all about you can see the code and you can test with the code. All right. That's why it is white. All right. It is visible to the testers and they can test and all of that. All right. So and they can improve design just because they are conducting a white box testing. So it's a testing technique. So, and there's also a testing technique called black box testing. It is the opposite of white box testing. This is what a lot of testers do more. Well, give me an example of white box testing. We have mentioned one black box testing in this class today, severally. We have mentioned a lot about white box testing in this class today. So, who can remind me an example of white box testing before I move on to black box testing? White box testing. Anyone?
I
Anyone?
didn't get the question.
Okay, so the question is, give me an example of white box testing. We have mentioned it in the class today.
Unit
Yes.
testing.
Anyone that can remind me, give me an example of white box.
Non-functional testing.
Unit testing.
Great. This person is really getting it. Okay, great. So unit testing is an example of white box testing. It is also called what? Component testing. All right. So the fact that I kept mentioning your code of line, your functional code and all of that, you write a function and you write a test function to run through that function. That means that you have access to that code. So in white box testing, the software's internal structure and design are seen and they are tested to verify the input and the output flow of the application. But in black box, you don't get to see the codes. The only thing you see is the already designed application. All right. So black box testing involves testing a system with no prior knowledge. So you don't have the knowledge of it. You're probably just new to the application, so they give you your test. What kind of application you can even explore it? There's something called exploratory test. It's an assignment. You go and I will add it to your assignment for the week. Okay, so you explore the application and then you put do input output. After all, nobody taught you how to use a banking app and you know how to use it. All right, nobody taught you how to use a gaming app and you know how to play your games. All right, so there are applications like that. You just lay your hands on them and then you start moving around, start using them. All right, so there's something called exploratory. So in black box testing, you don't get to see the code. You see the application and then you run your test. All right. So black box testing involves testing a system with no prior knowledge of its internal working. A tester provides an input and observes the output generated by the system under test. This makes it possible to identify how the system responds to expected and unexpected user actions. Its response time. So you get to know the response time, you get to know how usable the application is, and so on. So example of black box testing, we have functional, we have non-functional, we have regression, and so on. So black box testing is what a lot of testers, a lot of QA engineers. Sorry, can you help us mute? Can you help us mute your microphone, please? All right. So let's continue. So we've said that black box is what a lot of testers do. All right. So and when you are conducting your functional test, what do? You identify your input data. There's something they call test data. Test data is something like your email. Email, enter password. All right. I want to log in. I enter my email, I enter my password, and then I log in. That is a test data. It could be my real credentials. It could be a fabricated data. That's why we call it test data. It was randomly designed so that I can use it to test. All right. And phone number. And sometimes you are testing some form fields, and you need more mobile number to test with. You need bank account to test with, and all of that. So the developer will sit down and just develop some test data for you, make it available for the tester, and then as a tester you sit down with that application, you enter those things. That's what we call what test data. You enter, that's like your input. You identify your test inputs. Like I said, your email, your password is like your test input. You use that to log in. Then you compute the expected outcome with the selected input value. So when you log in, what do you see? Will you see an home page? All right. Will you see like a navigation video that will say, welcome, let us help you go through this module. There's some apps that once you log in the first time, it will show you some navigation videos, and then you have to click on next in order to close the thing before you actually even see the home page. All right. So what do you see after logging in? All right. So what is the outcome? All right. Then you execute your test cases, and then you compare. All right. So there is an expected outcome, or there is a way that app is supposed to behave when you log in. Now, if it is not behaving the way it's supposed to behave after you log in, then you have to compare what you have seen with what you are expecting. That is, what is the actual thing you are seeing right now as you logged in? Login is your test case. User login on a mobile phone or something, or web app. User login is like your test case. You are saying, okay, this test case, user login, I want to log in into the application with a valid email and a valid password. That is the test case. All right. Now, and I'm saying that for me to do a login, I have to input an email and I have to input a password. Now, after I put in email password, then I have to click on what? On login button. Now, after clicking on login button, there is an expected result that I need to see. Now, my expected result is saying that when I log in, I should see the welcome page. Okay, I should see what? The welcome page. So what now happens? Let's assume that this particular application has a defect at the login. And then you click on login, and then you discover that user cannot see that welcome. The welcome is not there, even though you're on the home page. All right. The welcome is not there. You are on the home page. So the expected results is different from the actual results. That's just the fact. The fact that you're on the home page doesn't mean that it is correct. But that welcome is not there. All right. And in the requirement document, it says that user should see, as a user, when user log in, they should see the welcome home page. All right. And then maybe they just put the what they should see. Welcome. Temitope. All right. So maybe let's now tested and discovered that welcome Temitope is not there. Even though they can see the home page. Is it correct? No, it's not correct. All right. So that is how you do your functional test. You now compare your actual results to your what? To your expected results. And at the end of the day, if both does not match, what do? You fail it. That means that test has what? Has failed. It has not passed because what is designed is different from what is in the requirements. Now, I think we are getting to understand it better. So, how to do functional testing? The following are the step-by-step process to do functional. Number one, understand the functional requirements. understand what the requirement is. 2, identify the test input or test data based on requirements. 3, compute the expected outcomes with selected test input. What do you expect to see if you make use of this test data? And 4, execute the test cases. 5, compare actual and expected results. All right, so we will move on. Types of testing. We are still on types of testing. There is one type of testing called change-related testing. You will get to see this often when you work with IT firms especially. So they continue to change or to add features to their application. Facebook, for example, when they started, it was not like that. The interface especially was not like that. All right. The way people add their profile pictures was not like that. The way you add your profile details, location, everything, it was not like that. But with time, they started adding features, they started improving their versions, version 1, version 2, version 3, version 10, and all of that. So change-related testing is important to know that. When an application, an existing application, when you start making changes to them, how do you test this kind of application? All right. So when changes are made to a system, either to correct a defect or because of new or changing functionality, testing should be done to confirm that the changes have corrected the defect or implemented the functionality correctly and have not caused an unforeseen adverse consequences. Especially if it is a very big application. If new features are added and somehow defects are how will you perform your testing such that it doesn't break the entire application? And then you just discover that one day Facebook is no longer there, at least for 2 minutes or for 5 minutes. It has happened before. All right. The Google was down. All right. So let's continue. So because of unforeseen circumstance, how will you test applications that requires continuous changing or addition of features? All right. So there's something we call confirmation testing. After a defect is fixed, the software may be tested with all test cases that failed due to the defect, which should be re-executed on the new software version. So the software may also be tested with new tests to cover changes needed to. So the first kind of test you run is the new features that were added. So you write test cases based on those new features and you run the test. Now the next set of tests you write are the ones that failed as a result of adding those new features. All right. Now, after this, you write a full test that covers the entire application. All right. And then you run it. Don't worry, for large applications, they already have their test cases. All right. And so they can always run it to check that these new features has not affected the entire application. And that's the essence of regression. This takes me to regression. So confirmation will confirm the new features. Regression will go back to the entire application and reconfirm. Right? So it is possible that a change made in one part of the code, whether a fix or another type of change, may accidentally affect the behavior of other parts of the code, whether within the same component, in other component of the same system, or even in other systems. So what we are saying is a change. Oh, we don't really have much time left. Okay, so we are saying that a change in this new feature may affect some components in the old application. Because of that, we need to run a regression test. In fact, this is where automation comes in. But today is not a day of discussing automation. All right. So you run a regression test and then you check that something has not broken in the application. So we have maintenance tests. This happens for applications that are being used already. all right, that are already deployed to production environment. We call it production environment. There's testing environment, that's production environment. Testing environment, when you're testing a testing environment, you don't make use of real data. Like I said the other time, they might be fabricated data, developed data. We just develop it, we just use it, and we use it to test. All right, you test it you test it in a testing environment. But in production environment, that is where your real users are using. All right, the application is already pushed to life. We call it pushing to life environment or to production. So here in this environment, people can access it. You can go online and search for it, and you will find it. Why? Because it is made available already to people. Now, there are certain tests you conduct, we call it maintenance tests, on this kind of applications that are live, that are in production. And so we call it maintenance test. So maintenance test is needed to preserve and improve. So sometimes your customer will complain that, oh, this thing, we need it to be in this place. It is in this side. Why not move it to the left-hand side? All right. And then developers will go back and then they will change that. And once they change that, they still need to test again. So that is where maintenance, you continue to improve the functionality and the quality of the application. That is what maintenance testing. All right. Now, this is where our assignment ends. However, I am going to add one more assignment to it. Research on certain smoke. Okay. And regression test. Okay. Now, also compare and contrast sanity and smoke. Okay. So this assignment is due by Tuesday, February 14. By the way, happy Valentine's. It's intentional. I intentionally put it to Valentine's Day so that before you start eating Valentine cake, you can submit our assignment. All right. So from today, you can start working on it, start researching on it. There is but the major question, the major assignment I want you to focus on is this one: from a product or a business analyst perspective. Highlight the business requirements and business rules to design an ATM machine. Now, let me explain in case you don't know what business rules are. I think I'm trying to keep the time. Okay. So, business rules, they are like conditions, preconditions, post conditions. All right. That maybe the application on that test has to fulfill. Okay, before they are passed. All right. Now, for an ATM machine, for example, I mean the machine you're all used to, the payment machine. Now, how do you think the ATM software was designed? As a user, what do you do when you try to make a payment? Of course, we know that it is not making payment alone, that ATM machine, that is not the only function ATM machine does. It does deposit, it does withdrawals, does change of PIN, it does a lot of things, right? All right. So if you are looking at ATM machine software, all right, from the perspective of a business analyst or a product manager, you want to design a software like an ATM machine software. All right. Let's assume that it is a big idea, that it doesn't exist. Okay, let's assume it doesn't exist, and it's a very big idea, and then you are forming the idea. Okay, I want to design an ATM machine software. Okay. Okay. How will you analyze your design requirements? If a developer is supposed to work on it, what will the developer develop in his application? What will be required in that application? That is what I need you to work on, to research on. All right. So this, I'm giving us this to give us a particular mindset. When you come from a mindset of a product owner or a business analyst, there is a way you think as a tester that will inform or improve the way you will test the application. All right. So let's start with that. Let's see how many of us can come up with a business requirement document. All right. Can come up with a business requirement document with business rules. Okay. If you don't know what business rules, you can check online. Is there? Right. So a business requirement document with business rules that will list, all right, how an ATM machine should be designed. All right. So that is the assignment I'm giving us. Now the next thing is question and answer. I will take any question now. We should have 30 minutes. All right, Mohammed, you can unmute now and ask your question. Let's start with you. Usman, unmute your mic and ask your question. Hello? Is Mohammed there? Okay. Okay, someone sending a question. Yes, Dolapo, Dolapo, you will, we are still adding it though. I don't know what said, are we still adding the questions on differences between smoke and unit testing? As an you're adding it though. See, this one is a serious matter. Oh. This training is serious for you. You know why it has to be short? I don't want us to postpone it so that you won't forget what you have learned today. So there is a reason for it. So you will be able to like have a faster grip of whatever you have learned. All right. So we are adding it. I've added it already. All right. So let's okay. So Mohammed, I've seen you. You can ask your question. Ask your question. Like unmute your mic. Unmute yourself. You are muted if you are talking. Okay. Maybe we have to wait for Mohammed to unmute and answer Patrick. Patrick, you can unmute your mic if you can hear me.
Yeah, I can hear you, Abiola. I don't know if you can hear me.
Okay. So now ask your question.
Hello, can you hear me?
Yeah, I can hear you.
Okay, thank you for the class. So I want to ask now, because okay, the question I want to ask is from the user side. Let us assume that I'm a user. I don't have anything doing with the programming and the testing. Then along the line, I discover a fault in the application.
Okay.
Yeah, so I discover a fault on the application or the software, and then I report. I don't know, a term. Is there any term for that?
Okay. So you know Google Play Store, right?
Yes.
Or Apple Store. You know they have reviews like that.
Yes, they do.
So when you push your mobile app to Google Play Store, maybe as a developer, you have developed and push it.
Yes.
And then someone gets to download it and use it. You know, they can actually add a review of that application.
Definitely they can.
Yeah. So that is what happens when an application is not tested and then it is pushed to places like that. And then you push it to the user and then they start using it and then they are so annoyed and they just give a very bad review. All right. So for now, I think those are the only checks. For Apple, you have My Store. You are, for Android users, you have Play Store. Right. If I understand what you're saying, as a user, that is where you write your reviews for applications that you are not satisfied with.
Okay. Yeah. Thank you,
Yeah.
Abiola. Yeah.
All right. You're welcome.
Hello.
Yeah. Hello, Mohammed. I can
Yes.
hear
Good
you now.
evening. Yeah. Good evening. Sorry for the initial struggle.
Okay.
First, thank you. Thank you so much for this opportunity and platform. My question
All
is
right.
number one. What are the materials that one would need to succeed as a software tester? Then, secondly, do we really need a certification to thrive as a freelancer software tester?
Okay. So the skills you need to be successful as a software tester, I think,
No,
is one of the
I said the materials.
okay, the materials you need.
Yes.
Okay. You materials. Well, there are a lot of materials online, I must say. There is Guru 99 sites. There is ISTQB syllabus. That's the International Software Testing Qualification Board syllabus. They have a document that you can go through. Then in fact, there are lots of materials online.
No,
There
when I say materials, looking at like gadgets, I mean stuff like.
okay. You mean resources you need,
Yes.
like
Yes.
your laptop, and okay, I get the point. Okay, so definitely as a tester, you will need devices like laptop, mobile phone. All right, you definitely need it, so you can't do without it.
Okay.
All right, you need a standard mobile phone, whether Android or iOS. Then you need a laptop or desktop.
Okay.
Yeah. Then you will need to you need access to materials that you can read up. All
Okay.
right. Then you might need to lay your hands on projects. You can start with some static projects. For example, like Patrick asked the other time, go to Play Store or go to iStore, look for applications with bad reviews, download them, go through them yourself. All right. Try to test them.
Okay.
Try to find out what defects those applications have. All right.
But
So those are ways of improving your skill set even before getting to work with any company.
no, but in such random application, how can we test them when we don't have access to the test requirements? In such
Okay.
case,
Okay. So for test requirements, you might need to work with as an intern, or you might need to work with someone that can help you on that. um but you can actually test an application without having a requirement. I talked about exploratory testing the other time. So one of the research you still need to do as from this training, you need to take home, is research on different types of software testing. There's something called exploratory testing, meaning that you don't have access to the requirement documents. All you have is the application, and when you have the application, there's little that you can do. So they call it exploratory. You explore it and then you bring out the test cases from your exploration.
okay.
All
Okay.
right. So
Yeah.
there are cases like that. But if you really want to work with business requirement documents, if you continue with this training, then we're going to have a practical session for that.
Okay. Okay. The
All
other
right.
question is about the certification. Do we actually need to get certification, to actually thrive and
Um
succeed?
Actually, you need it at some point, but it is not now, because you will really need to have a real experience and hands-on, so that you
Okay.
won't just go and read and pass like some people do in schools. You read and pass, and then they come out and they can't really explain what they've learned and all of that. So you really need to have experience, work with companies, organization, experience individuals, boot camp and all of that. work with them, learn at least for a year, all right, before you write the exam.
Oh, okay. Okay.
Yeah.
Thank you so
Some
much.
companies require it as a bonus, as an added advantage. If you look at their job requirement, they will say ICQB certificate is an added advantage and so on. So some of them require that as an added advantage to give you an edge.
Okay. Thank you. I appreciate it.
All right, you're welcome. Okay, I have Bishop. Bishop, you can go on with your question.
All right, thank you, madam. Good evening, everybody.
Yeah, good evening.
Yeah, so once again, madam, I want to use this opportunity to say a very big thank you for this platform. It's
You're
really
welcome.
impacting. Yeah. So the question is, how long can one, go through this training before we can, be good in it or probably get a job somewhere?
How long can you learn before? The truth is, it does not have any length of time. But 1 month is okay. Just like you are doing 1 month now. And from 1 month, you can start an internship. If you are
Okay.
lucky enough, you get an internship with a company. And then from there, you progress. Become a junior QA. Then from junior QA, you become mid-level and then senior and lead and all of that. All right.
Okay. Yeah, so but this is not my first trainings. I've done a 1 month training with a platform before now. So but I after the training we were issued a certificate, but what really happened was my laptop crashed. So it took me a whole lot of time before I could get another. So but what they told us was after the 1 month training, they actually introduced us with another 3 month training. So but we couldn't go further. Some people went further, while some dropped, and some went for 3 weeks program. Then after the 3 weeks, they got job. Some are working currently now. So that was why I asked the question that how long can one, because it's really a good one if one put a lot of effort in it because
Yes,
really.
yes. It doesn't, like I said, does not take time. What is important in software testing is hands-on, practicality of all of these things you are learning. So, for example, if you are done with this training and you get to work on projects, because there are some projects that that are in form of contracts, they are all around us. All right. So you just need to connect with the right people. So they are all around us and they are looking for testers. We need testers to test this project, and then there are many testers on it. If you can get those kind of project, you get to work I work on it for like 3 months, 6 months. Some of them are 3 months, some of them are 6 months. Then they need software tester to work on them. Well, by the time you start doing that, you start gaining experience. All right. So from there, you can get an intern job. All right. Then get a junior QA role. The timing is not really fixed, depending on how fast you learn. I must say.
Exactly.
Yeah.
Thank you very
It's
much,
not
ma'am.
really fixed. Yeah. You're welcome. So in the absence of none, in the absence of no more question, I'm assuming nobody has any question left. I'll be assuming we all understand today's training, and that's okay. Adedolapo, you can ask your question.
Okay, ma, please, I would like to know where we are submitting the assignment.
Okay, yes. You are submitting it to my email. I will communicate that on the Slack channel.
All right, ma. Thank you, ma.
I will have said the Slack channel, but we don't have much space for files on the Slack channel.
Okay.
So you just send it straight to my email.
Okay.
I think I'll create a Google Drive or something. You get to submit it and all of that.
Ma, please, I don't know if you can help me.
the Slack URL in the chat box. I'm having issues refreshing my email.
What do you say? Can you come again?
You can let me drop the Slack URL in the chat box. I'm having issues refreshing my email.
Okay, the Slack link.
Yeah.
Okay, you are not on Slack yet.
Yeah, I'm not.
Oh wow.